In this video, I want to solve this equation, and I want to do it by factoring, but I'm going to do it two different ways so I can accentuate a couple of different strategies for solving these types of equations by factoring. So this video is going to deal with one of those strategies, and I'll save the other strategy for another video. Okay, so here we go. We look at this. We've got a lot of terms going on, and we also have terms on the left side of the equation and on the right side of the equation. So let's go ahead and distribute through here first so we can get rid of the parentheses, and then we're going to move all the terms over to the left side, because in order to solve an equation by factoring, all the terms have to be on one side of the equation, and then I need to have it equal to 0. So let's go ahead and see what that looks like first. So I'll distribute everything. So that'll be 5x to the fourth plus 6x cubed minus 4x cubed equals, looks like 20x squared plus 24x. Okay, so these two terms I'll push over here to the left side, and I'll just change their signs as I do so, because I can change the sides of a term if I change their signs. So minus 20x squared minus 24x, and that equals 0. Okay, so we have this whole left side here, which is going to be one big algebraic expression that we need to factor now. So you'll notice here a second, I didn't combine these two like terms. Okay, there's a reason for that. But let's go ahead and factor out the greatest common factor of x first, and then I'm going to show you why I did that and where we're going to go from here. So once I take that x out, I have x to the fourth plus 5x cubed plus 6x squared minus 4x squared minus 20x minus 24, and that equals 0. Okay, so if I had combined these two together, then I would have 1, 2, 3, 4, 5 terms. And I can't use factoring by grouping if I have 5 terms, because 5 is a prime number and I can't divide that into an even number of groups. Okay, so I'm going to go ahead and leave it with 6 terms by not combining these. And then what happens is I can, in fact, group 2 groups of 3 terms each. Okay, so I have this x, which is my greatest common factor, and let's go ahead and tackle these problems now. So it looks like in this first set of 3 terms, I can pull an x squared out. And when I do that, I'll have x squared plus 5x plus 6. And for my second group, it looks like I can pull a negative 4 out. And I will have the same thing when I divide that all out of those terms. Okay, so I have this, and my x squared plus 5x plus 6 seems to be the leftovers. They're the same, so I can actually factor these out, because this is the way my grouping goes. So x squared plus 5x plus 6, and then of course the x squared minus 4, and that's going to be from the greatest common factors of each of those groups. Okay, so taking a look at this, this can factor down more because this is a really nice quadratic trinomial, and this can factor down more because that's a difference of squares. So we're actually going to have a lot of factors in this problem. So I'll leave the x out front, and here we go on this one. So if it's a quadratic trinomial, we notice the leading coefficient is 1. So I just need to ask myself, what 2 numbers multiply to make positive 6? That add to make positive 5. And because that leading coefficient is 1, I know the factorization will end up looking like this, because the x times the x makes the x squared, and everything else will fall into line once I have these answers to these questions. So if they multiply to make 6 and add to make 5, seems like that could be a positive 2 and a positive 3. And you can multiply that back out to make sure if you like. Okay, so x squared minus 4 is the difference of squares. So x squared is a perfect square, its square root is x. 4 is a perfect square, its square root is 2. And we have 1 minus and 1 plus. Okay, so we have our factorization here, just like this. It looks like this x plus 2 occurs twice. So when I put this all together, it'll be x plus 2 quantity squared. And then I have this x plus 3 and x minus 2, and that's going to equal to 0. Okay, so we have now fully factored this left side, this big algebraic expression that we started with. So now it's time to use our zero property of multiplication. Because I notice I have 1, 2, 3, 4 unique factors, and I'm multiplying them all together. And when I multiply them together, I get 0. So that property says if I'm multiplying all these things together and I get 0, well, one of these things has to be 0. But I'm not really sure which one it is, so I'm going to account for all of them having the possibility of being 0. So I'm going to set the first factor equals 0, the second factor equals 0, the third equal to 0, and the last one equal to 0. And I'm just going to go ahead and solve all 4 of those. This one's already solved, x equals 0. This one, when we subtract 2 from both sides, will give me an x equals negative 2. This one, when I subtract 3 from both sides, will give me a x equals negative 3. And this one, when I add 2 to both sides, will give me x equals 2. So I have 4 different values here, so we can write them all as 0, plus or minus 2, and then negative 3. Okay, so these 4 values are going to be the solutions to this initial equation that we started with here. And the strategy that we used here was just distributing through, getting all the parentheses to go away, getting all the terms on the left side. But the key to doing this was not combining these two like terms. So I had 6 terms, and I was able to group this evenly, and then I factored it and solved it by factoring.